Hello and welcome to the demonstration of the tutorial 3D Tailings Storage Facility. My name is Marina Trevisoli and I will be guiding you through this video. So this example is used to illustrate the analysis of a three-dimensional tailings storage facility. The model will be analyzed with the grid and tangent search method for circular slip surfaces. The purpose of this model is determining the factor of safety of a tailings storage facility. So let's get started. First step when we initiate our PLAXIS 3D LE software is specifying the analysis settings. How can we do this? So here under Model, we can click on Settings, and the Settings dialog include the information in terms of adjusting the searching calculation methods used in the analysis. In this case, we are keeping the search method as grid and tangent, and we can also select the slip direction. We are keeping towards positive X, or we could select as well right to left in XZ plane, or even multiply orientation when our model is not necessarily aligned with the axis. The next step is the calculation method. We'll select here the Gri-Fedlin method to be used and the analysis method as one direction method as well. We'll click OK. And the next step is entering the geometry of the model. The model geometry is defined as a series of layers and can be either drawn by the user or defined as a set of coordinates. In this case, we are going to import the surfaces of the model and also include the coordinates of the region, which is the boundary of the model. So the first step is here under Geometry. We're going to click the Regions dialog. And by default, we have Region 1 here. So what we're going to do is click on the Properties. And based on our tutorial, we have the coordinates X and Y for the region. We're going to click on New Polygon and paste the coordinates. User could also type the coordinates manually. All set, we'll click OK. So region 1 now has a polygon associated with 4 points. And we'll click here OK. OK. And here is the region of our model. The next step is importing and defining the 6 surfaces of this model. So in this case, we are going to click here under Geometry and selecting the Surfaces dialog. And by default, PLAXIS 3D LE keeps 2 surfaces in the model, 2 constant surfaces, because for a layered cake approach, between 2 surfaces we have 1 material associated. So in this case, we're going to select the surface 1, click on the properties, and in this case, we are going to define that the surface 1 is not a constant elevation, but actually a grid. By doing this, we can import the data grid related to this specific surface. So in this case, we can come here under Import Data Grid, or we can even select here Paste Data Grid. If we click on Paste Data Grid, we can import from File, and navigating through this specific directory in my computer, I can access the tutorials file. So now I need to identify the file with the corresponding name for surface 1. If I follow the tutorial, this surface should be called Slope Stability Tutorial 3D Tailings. Here we are. 3D Tailings Storage Facility Surface 1. So as we can see, we're going to import all these 6 surfaces, and they refer to a data grid that is actually the CSV file, so a comma separated value. I'll click here on surface 1, double click, and then the data grid would be included here for us. We can now click OK, and then the software will ask if I want to keep the existing grid points. I'll click on no because I want to include the new points. And here we have our first surface included, which is a grid. I'll click OK, and the next step is doing the same for surface 2. So I can come here under the properties, switch to grid, click on paste data grid, import from file, and in this case, I'm selecting the surface 2. Same way, I will click OK, no, OK, and surface 2 is included. So I have 4 more surfaces to include. In this case, I will create a new surface. So I can say that I want to create 4 new surfaces, and the type of new surface is actually a grid. The surface name here will be defined, will be as default following the number of surfaces, and these new surfaces should be at the top of the model. Okay, and we have now the other 4 surfaces that need to be included. So in this case, I'll click on surface 3, properties, and paste the coordinates as well. So surface 3, okay, no, okay. Same thing for surface 4, properties, paste data grid, import from file, okay, no, okay. 2 more, surface 5, properties, paste data grid, import from file. We'll select here surface 5, okay, no, all set. We can even check the minimum value of the data file, which is 0, and the maximum value for X, Y, and Z coordinates, and the quantity of points to make sure that we are importing correctly. Click OK. And the last surface, which is the top surface of our model, will be surface 6. We can click here on paste data grid, import, and finally, here we are with the coordinates. Okay, click OK, and all my surfaces were included in the model. So after including the surfaces and making sure that the region has the right coordinates for the model boundary, you should see on your screen this visualization of the model. So we can see that we actually have, in this case, a layered cake model. So if we switch to the XZ view, we can actually see that the surfaces are composing the layers. So here we have a layer, a material, here we have the dam material, and the subsurface as well. If we take a look on the, using as the reference the y-plane, we can see the changes on the geometry of the model, slightly here on the dam, and also here on this layer on the bottom of the dam. So let's return to the 3D view. The next step of our tutorial is defining the pore pressures. The pore pressures can be defined here, pore water, under the settings dialog. And in the settings dialog, we need to define the pressure method used to define the pore pressures. In this case, we are going to bring a water surface to our model. So I'll click here on water surface. And I can pick water surface or piezometric surface. In this case, we'll handle the water surface. And when I click on water surface, I can also define the water surface water table as a grid, constant elevation, or mesh. So the dialog is pretty much the same as for surface geometry. So in this case, I'm going to do the same approach, base data grid, import from file, and I'm going to select here the information that I have in terms of slope stability tutorial, 3D tailings storage facility water. So this is our water level. I'll click OK. No. And here it is. So differently from the surface, I can apply the water level to a certain region or layer of the model. Okay, so in this model we have 6 surfaces, and consequently, as a layer cake approach, we have 5 layers. So if we keep selected here these options, we are making sure that the water table is influencing all the 5 layers of our model. I could also come here under the format and making sure that I'm visualizing the water table. I could even visualize the ponding in case that there is a ponding, and the show fill as well by adjusting the opacity. Okay, okay. You can see here our water table indicated in this blue surface. And the next step is creating the materials and also applying the materials to the model. So we can come here under Materials dialog. And first of all, we need to create the materials of our model. We have 5 materials in this model. And to do so, we can click here under the New. And we'll include the first material, which relates to the tailings. For this one, we can pick a method, a constitutive model. And for the tailings, we can define as a undrained strength model, so a soil undrained condition with friction angle equal to 0. Okay. When I do this and click OK, the material properties dialog will open up for us. And in this case, you can see we don't have the friction angle. And I will define the cohesion. So following the tutorial, I can define here the properties of my material. By doing this, I'll click OK, and I'll create the next material, which refers to the dam structure. The dam will be represented as a more coulomb. The cohesion in this case is 5. The friction angle is 37. And the unit weight is 20. Click OK. A new one. Structure fill, more coulomb. The cohesion I will set as 0 and the friction angle as 36. The unit weight I'm keeping as 20. Okay. The next one is the clay material. So the clay is also more coulomb. Cohesion as 20, friction angle as 18, and the unit weight in this case is 19. Click OK. The last one will be the bedrock. So the bedrock in this case will set as a bedrock model. Okay. Okay, we have created the materials, and the next step here come under the materials, material layer, and we will assign our materials. So top to bottom, we apply the tailings, the dam, the structure fill, clay, and the bedrock. So as you can see here on the drawing space, we have our model set in terms of the geometric representation of our model. We can see the water table, we can see the materials applied as expected. So the next step is applying the search method geometry on the model. So we define that we are going to use the gradient tangent, but we didn't locate yet the gradient tangent in the model. So how can we do this? Well, we have here this option, this dialog called slips, and the information available here will vary on the type of search method defined for the analysis. In this case, we have the gradient tangent. We're going to click here, and we need to define the coordinates of the grid and the tangent by pasting the coordinates, manually typing, or selecting the options here to draw the gradient tangent directly on the drawing area. So in this case, as we are following a tutorial, I will use the coordinates specified for this specific case. So I'm defining here the grid in terms of X, Y, and Z coordinates. You can see that different from the 2D, we can expand the grid on the third plane. And the tangent plane here, which is this one right here, and the number of increments as well. It follows the same structure as we would have in 2D, but of course extending on the third dimension. We can also set the changes on the aspect ratio and Y curvature for the extension of the ellipsoid. And in this case, for the aspect ratio, we can define some additional ones. So PLAXIS 3D LE will identify the critical scenario and also let the user know what was the aspect ratio, providing the most critical result from 1 to 2. And that's it. We can click on the 2D view and check how our settings of the gradient tangent look like. I'll click OK. As you can see here, defined. And in this case, the next step is actually running our analysis. So I'll click here on Solve and Analyze. We will save our model, and PLAXIS LE Slope Stability Solver will open up and calculate the sliding mass. Okay, so it seems that the analysis is finished. We can have an idea of the minimum factor of safety from this solver dialog, and we can click here after solving on the visualize results. So we can see that using the calculation method of GLE, gradient tangent, the minimum factor of safety obtained is 1.503, and the aspect ratio selected for the ellipsoid is actually 1.5, and the ellipsoid curvature is 2. We can check the information in terms of the minimum sliding mass on this legend over here. Some additional information that we can see in the model is, for example, clicking here under slips, critical sliding mass, and we can explode the sliding mass out of the model respecting a certain distance. So you can visualize the shape of the ellipsoid and the materials that are being associated with this minimum sliding mass. We can see that the majority here is in fact on the clay portion, so this failure condition is actually passing by the foundation of the tailings storage facility. If we click here under the YZ view, we can see the sliding mass on the 2D view and the depth of the sliding mass reaching, in fact, the clay layer here. We can see the crest and the tool extending, and if we would like to check the columns related to the sliding mass, by clicking on each of the columns, we can actually understand the information in terms of what was the base cohesion utilized, the normal forces, shear resistance force, the pore pressure as well based on the water table used, and other information. It's up to the user to return and visualize other types of variables on the sliding mass. So clicking on column-based information, we can decide to not only view the materials, but let's say how the pore water pressures look like in the sliding mass for the factor of safety of 1.5, as well as other information in terms of the shear resistance mobilized.